Ballot's Law. If an observer in the northern hemisphere feels the surface wind, the center of the low pressure is toward his right, somewhat behind him, and the center of a high pressure is toward his left and somewhat in front of him. If an observer in the southern hemisphere faces the surf wind, the center of low pressure is toward his left and somewhat behind him, and the center of high pressure is toward his right and somewhat in front of him. Ballot'S Law origin. The law was first introduced by American meteorologists John Henry Coffin and William Ferrel. This was then known as the Ferrel's Law. On November 1857, Christophorus and Decorus de Decorus, Vice Ballot. October 10, 1817 to February 3, 1890. Published complete contests rendus containing empirical validation of Ferrel's initial theory in 1856 known as the Vice Ballot's Law. This is William Ferrel and Christophorus Henricus Diodorus Vice Ballot. Nathaniel Bowditch, March 26, 1773 to March 16, 1838. The Vice Ballot's Law first appeared in early version of Nathaniel Bowditch, American practical navigator in 1900, and other publication to assist in passage planning and safe conducting of a ship in the sea. Application of Vice Ballot's Law. The general purpose of the law is to assist steering a vessel away from the center, in the right, in the northern hemisphere, or left. In the southern hemisphere, quadrants of hurricanes or anything other rotating disturbance at the sea. Other use is to help establish the probability of the existence of a storm and the best course to steer to avoid the worst of it. Observing the purpose of the law. The following are observed in establishing weather prediction to be confirmed with the law. Number 1. Visible flood formation. Number 2. Wind direction and speed. Wind vane and anemometer. Number 3. Atmospheric pressure barometer. Number 4. Other system. Vice Ballot Law on storm formation. How do storms form? The factors that contribute to the formation of the storm includes: Number 1. Water temperature at least 25.5 degrees Celsius or 7.7 Fahrenheit with the depth of at least 50 meters or 160 feet. Number 2. Rapid cooling with the height allowing the release of heat, of condensation and powering the cyclone. Number 3. High humidity. Number 4. Low amounts of wind shear. Number 5. Must be at least 555 km and 345 miles of 5 degrees away from the equator to allow Coriolis effect and deflect. Winds blowing towards the low pressure. Number 6. Operating existing weather disturbance. Location of a storm. The location of most storm formation is in between 10 and 30 degrees away from the equator because Coriolis effect initiates and maintains cyclone rotations. Cyclones vary from within 5 degrees of the equator. Strength of the storm. Hurricane intensify when moving over areas of increased water temperatures and regain over colder water surface. Upper atmosphere, wind shear, different wind direction and speed at different elevation, will frequently prevent or slow intensification of tropical storms. By spreading out the storm horizontally and preventing the formation of strong abrupts of warm, humid air, movement over a landmass will weaken. Hurricane winds but will result in a large-scale rain that can result in a large flooding. When encounter a strong frontal system, such as polar front, The hurricane were curved and track along the leading ledge of the front or became implanted in it. That's all. Thank you, sir.